Hi, my name is Gugi Simon, data engineer, and welcome to this YouTube channel, yeah, Data Community, where we discuss data engineering, everything data engineering from building pipelines, best practices, to different tools that are being used as we come to the end of 2024. And looking forward to sharing a lot of content, sharing a lot of value and engagement also. YouTube is an amazing resource to learn. A free resource. And let's get into it. So probably if you have heard of data engineering, there are so many tools that are out here. And confusing at times. You wonder, how will I learn all this? Well, it's a bit challenging, but it's doable, very doable. But some skills remain very vital in data. So we have SQL and Python. So we have SQL, Python used by data analysts, analytics engineers, and data scientists, and also data engineers. Very crucial for pipelines, for analysis. So we are going to get into SQL. So we are going to start a series of videos on SQL where we are going to do and learn how SQL is mostly used by data engineering when dealing with data pipelines, and dealing with data. So first things first, we cannot work on data that is in space or somewhere. The data needs to be in a database or in a data warehouse. And so there are guidelines, procedures on how to store this data. You don't just wake up and store data. There are, for data engineering, you need to store data that will be processed in the right way, and to make it easier for the business users, and to make it easier for data scientists and data analysts for further analysis and ML models. So there are many practices that we have. And so today we're going to be talking about data modeling techniques. There are three mostly commonly used. And so we're going to be discussing them in depth, and why each and which method is being used. The pros and cons, and situations where to use them. And we're going to be having a clincher where we talk for data engineering. This is the most preferred. And so the three, we have the one big table modeling. Then there's the Kimball, and then there's the relational data modeling. So this will be the context of what we'll discuss today. So let's get right into it. We have data modeling. And so it's crucial for designing databases that effectively manage data for analysis. And we have three common approaches, main approaches used by data engineers. We have the Kimball, one big table, and the relational data modeling. So let's get into Kimball methodology. And it focuses on building a data warehouse that is user friendly and designed for querying. Uses a star schema and a snowflake schema to organize the data. So we have star schema, shape of a star, or we have one star schema, that's the fact table at the middle, surrounded by other dimension tables. The star schema provides quantitative data, measurable data, and the dimension tables contain the descriptive of fact tables. And also we have the snowflake schema that has other highly denormalized data. And so in the dimension data, it also has other dimension data. So let's say a region is in the dimension table. And so from the region, we want to create another dimension table, probably saying the location, sublocation, the region north, south, east, of the location of the sublocation. So you denormalize the data, and so so that's basically the star, the snowflake. schema. Yeah, we have the key features. We have contains the tables and dimension tables. Fact table contains measurable data. Dimension table provide the context. And yeah, and so the mostly used schema is the star schema, which is easier for users to understand and query. Yeah, so we have the pros of Kimball methodology. Uses it's user friendly business users and analysts. Yeah, very easy to understand. Mostly in cases where the star schema is used, yeah, it's direct where you have an ARD diagram drawn for you before the analysis and before the data modeling is done. It's very easy to understand the attributes. Yeah, and simplifies query performance and access to data. Yeah, and facilitates faster development cycles through iterative design. So the design is the same. So you just need to get the facts right. And the facts, I mean the data that will be in the fact table, the quantitative measurements that you use, that your analyst and want to use, and the business problem that you want to solve. Yeah, and so we have the cons, also has cons, can lead to redundancy due to denormalization. Remember, when you use the Snowflake schema, we'll have denormalized data, and so this introduces redundancy. Yeah, and may become complex with many facts and dimension tables. At times, you may find yourself overdoing this. Yeah, and you find you have so many dimension tables that relate only to one fact table, and there's so many joins and there's so many relationships, so it becomes at times difficult to understand, difficult to query, difficult to analyze. Yeah, and so more challenging to maintain as the business and the data grows. So as this data increases, it becomes more challenging to maintain it. So because there are other, the schema tends to change. Yeah, so it becomes harder and challenging to maintain the system. So when to use the Kimball methodology, we have ideal for environments where data is frequently queried and needs to be accessible to business users. Yeah, and focused on organization, focusing on analytics and reporting. Yeah, and so basically the Kimball is built in data warehouses. We have the three data warehouses mostly used. The four now, we have the Azure, the Redshift, Amazon Redshift, we have the BigQuery, and we have the Snowflake. Yeah, so data modeling is done using another tool that we are also going to be discussing in this SQL series, DBT. Yeah, so DBT does this. Yeah, so we're going to move on to the next. We have the one big table modeling, and this approach consolidates all data to a single table. It's simple and straightforward, but can lead to large unwieldy tables. Yeah, so we have all the data in one table, and there's no data modeling, there's no database normalization. Database normalization and relational data modeling is the next that we're going to be talking about. Yeah, and so the key features, we have the data includes the facts that dimension table in one single table, and often used in applications where simplicity is prioritized over performance. So the trade-off is the computation. So you want simplicity and you don't want performance and computation. That's the trade-off that you're going to use. Yeah, and so it's not commonly used, but there are ideal scenarios where it is used. Yeah, so pros of this technique, it's easy to implement and manage. Yeah, so with only one big table with all the data, so it's easy to manage and implement, and simple queries since there is only one table to deal with. There are no joins, there are no relationships that you need to establish. Yeah, so the cons is poor for performance for large data sets, as the table can grow extremely large. Yeah, and lack of normalization can lead to data integrity issues. So we have, when there's no data normalization, when the data is highly denormalized, so the integrity and the accuracy goes down. Yeah, so it's ideal for some situations where there are smaller data sets where performance is not a critical concern. Yeah, and where there are simple applications. So you can use this technique, not majorly used, but used, and it's becoming frequent. Yeah, but there there are so many trade-offs that will come about with this technique. Yeah, so basically for small data sets, when you involve large data sets and you use this, then you're going to have a big problem for yourself. So relational data modeling, yeah, and so it's a foundational concept in database design that organizes data into tables with defined relationships among them, widely used in RDBMS, relational database management systems. And the key features, we have tables where we have rows and columns, yeah, and we have the primary and foreign keys. There is normalization of data normalization. You remember you have the one normal form, the second normal form, and the third normal form. The ideal industry practice, although it reaches to the sixth normal form, but up to the third normal form is the ideal industry practice. Yeah, and it's the process of organizing data to reduce redundancy. So that's normalization. Yeah, and so the pros of this is the structured data, making it easy to query and manage, and the ACID properties support reliable transactions. So the cons we have can become complex with so many relationships. Yeah, normalizing can lead to performance issues. Sometimes you overdo it. Sometimes depending on the data is different, and so depending on the data, when you do the first normal form, second normal form, the third normal form, yeah, where remember the third normal form, the second rule that all relationships must not be transitive. There should be no transitive relationship. So this leads to performance issues where you will need to normalize the data further and further. So that becomes an issue. So it's not optimal for analytical processes. Yeah, so it's all up. So it's not optimal for all up, it's optimal for OLTP. Yeah, and so when to use the relational data modeling is when dealing in transactional system. So where there are systems requiring update, insert, and deletes. Yeah, best suited for structured data. Yeah, and data that changes frequently, and where maintaining data integrity and consistency is key. Yeah, so these are the three main types of data modeling techniques. Yeah, so after looking at the three of the data modeling techniques, we have one that stands out, one that is ideal and recommended for data engineers. Yeah, and it's the Kimball. We have the star schema and the snowflake schema. And this is mainly used in the modern data stack, yeah, where we are using the ELT pipeline approach. Yeah, so you get the data into the data warehouse, and we use the computation power of the data warehouse to get analytics. So it's a blend of performance and analytics. So that's why it's been preferred to the other two data modeling approaches that we have talked about. But these also, it's dependent on the business requirements and the tools that are accessible in the infrastructure that you have. Yeah, and also on the business requirements and end users of the business will dictate the type of data modeling technique. But the Kimball remains the most recommended and probably be one of the best in recent times where we are in the modern data stack. Yeah, and so don't worry about that if you have not interacted with the Kimball method. That's what you're going to be delving in this series of SQL, where we are going to get data into data warehouse and start building this using SQL and DBT. So don't worry, got you covered in that. Yeah, so that will be all for today. Till next time, like, share, and subscribe. Thank you.